record and then let's begin here. Okay, everyone, welcome back to another beautiful day. Let's go through what we went through last week real quick. Just a quick recap, guys. Basically, last week we talked about how light rays are going to behave, right? Light waves are going to behave very similarly like how the water waves behave as well. And in terms of your IGCSEs, usually they like to ask you this one specific question. Let's say, for example, today they give you a mirror here. This red color line represents a mirror, right? And then they have an object here, okay? This is the object here. They'll ask you to draw two light rays to locate the position of the image here. And if you're ever asked to draw the two light rays, guys, I want you to know that you are always supposed to draw the V-shaped light first. What do I mean by that? Let's imagine this is the point of interest that we're looking at, right? And if this is the point of interest, first and foremost, we're going to draw two light rays. The light rays are going to hit the mirror here, right? Which obviously is going to be reflected away from the mirror, right? This is the first light ray. And the second light ray will behave the same thing. It will hit the mirror here, and then it will be reflected away from the mirror. These are what we call real light rays, right? So how are the images formed? The images will be formed when the virtual light enters the mirror. And when I talk about the virtual light entering the mirror, I'm basically talking about this part here, the dotted lines that you see here. These dotted lines are basically supposed to be in one straight line with this line here. The only reason why it is not straight now is because I'm drawing freestyle, right? But bear in mind, guys, these virtual light should be one straight line with this one here as well, guys, okay? And wherever the two dotted lines intersect, that is essentially where the image is going to form. In other words, this is the point of interest of the image, and this is exactly the image are supposed to be the same thing. It's just that it's poor illustration skills, but you guys must know this. This is a very, very, very common question in your IGCSEs. A very common mistake that students make is that when they draw the image here, they don't know that the distance here to here should be the same distance from here to here. Because if you think about it, a mirror is basically just a reflection of everything, right? However far you're standing away from the mirror, the image should be standing however far away from the mirror as well. Okay, so they should be equal distance. I mean, say, if let's say here was 5 meters, here will be 5 meters as well. A very, very common mistake with these students. Oh, what is Abigail? She's supposed. What the hell? I think the St. John students. Do you know? Do you guys have any St. John friends? No? Yeah, I think the St. John students are having an event or something. But it doesn't really matter. But anyways, this is how the image is supposed to look like, guys. Very, very important. If you must remember, you can kind of remember this in the form of like the fish, like when you're in kindergarten, when you had very poor drawing skills and your teacher asked you to draw a fish, right? Like this is that fish right there, right? Then usually we'll draw the eye here, and then this is something, and then it could be either a happy fish or it could be a sad fish, depending on whether you got candy or not that day, right? So this is essentially how you're supposed to remember it. It's going to be like the fish diagram. All right, everyone, very, very important. Okay, then after that, after we talked about reflection, we also talked about refraction of light. Refraction of light by definition, guys, refraction of light by definition is due to the change in speed of wave, guys. This is due to the change in speed of the wave, guys. If you recall refraction, I gave you an example of very commonly experience of refraction, right? Basically, if you have a cup of water here and then you put a straw in it, right? Usually if you look through the cup, you'll notice that, oh, why is my straw bended? It's kind of like a crooked way. It's not like one straight line now. It kind of bends a little bit, right? The reason why the straw bends, right, is due to the fact that there is a change in speed of light. Imagine this is your eye, right? If I look at the image here, because the light is traveling in air, right? And if it is traveling in air, the speed of light is 3 × 10⁸ meters per second. This is how the speed of light works, right? But when the light enters the water here, obviously, because it's a more dense medium, the light is actually going to slow down. And because it slows down, maybe, I don't know how much is it, but maybe it is 2 × 10⁸ meters per second. And due to this change in speed of light, this is why refraction occurs. A very, very common example in your IGCSEs is they'll give you something like this. Okay, they'll say that, okay, this right now is the pond of water. Okay, then right now there is a very ugly fish here. Oh God, this is too ugly to accept. Maybe something like this. Okay. Yeah, something like that. Okay, so if let's say there's a fish here, and then they say that your eye position is somewhere around here, right? They ask you to locate the image of the fish, right? What you're supposed to do is, yet again, you're supposed to find the point of interest, right? With this point of interest, you're supposed to draw 2 light rays, guys. The most important thing is you need to know that you're supposed to draw 2 light rays. And if you draw 2 light rays, it will look something like this. You're going to draw up and up like this. Okay, it's going to be yet again a V shape, right? And this V shape is going to connect all the way to your light here, right? And this light here will yet again, you're supposed to draw it, supposed to diverge as it goes into the water, meaning to say it's supposed to look something like this. And then wherever the 2 light rays meet, right, this is yet again a point of interest, and this is where the image of the fish is, right? And this is also the reason why it always seems much more shallow than it actually is, guys. The reason why it is much more shallow than it actually is because we as human beings, we perceive light to travel in one straight line. But in reality, when light enters a different medium, what's going to happen is it actually bends and looks something like this here, right? You don't really have to draw it, guys, because if you were to look at the notes, there is an exactly perfectly drawn nice diagram here. So please don't draw it, guys, because my drawing might confuse you just a little bit. What? It's so light. Lag in real life? What do you mean lag? Oh, light. Oh, oh, my bad. Yeah, but for those who have the printed version, please feel free to take an image of this. I'm very, very certain somewhere along the lines your exam, they're going to ask you to draw this image, and you must know how to draw this. This is like super duper important, very common in IGCSEs. You need to know how to draw this. Very, very important. Okay. Yeah, but most likely you're gonna end up drawing a very ugly one at the start, but with more practice, I'm pretty sure everyone here is going to improve one way or another. Okay. All right, so this is what we covered last week, right? I think we stopped here, right? So, you lie out there? No. No, it's not last week. It was the week before. Oh, because last week only right? Yeah, it's the 5th week, right? Holiday Okay, but anyways, this is what you're supposed to know. And today we're just going to move on with the refraction of light in a glass prism, guys. If you look at the next part here, basically, in order to understand how light rays behave, you need to understand how refraction occurs, right? So let's imagine, guys, today, right? I have a glass block here. Okay, this is a glass block, guys. This is a glass block here, right? So first things first is you need to understand that if today, guys, I have light entering the glass block that is perpendicular to the surface of the glass, what's going to happen is light will actually not refract. It will go directly down. This non-refraction of light when it enters from one medium to another can only happen if it is going perpendicularly down, okay? Or it could be perpendicular in this side. As long as it is perpendicular to the surface of the glass block, usually no refraction will occur. And you can even try to do this at home. You know, later on you can go, if you have a glass block or whatever accessory at home, right, shine a light down perpendicular. You'll notice that the light doesn't bend on. It'll go directly straight through, and it'll be more certain. It'll be more easy to see if you have a laser at home, right? But if the light does not enter at 90 degrees, any other angle besides 90 degrees, what's going to happen is light is actually going to refract. Light is actually going to refract, right? And meaning to say, depending on which situation it is, light is going to behave differently. For example, if today light is entering from a less dense medium, which in this case here is air, to a more dense medium, which in this case here is going to be glass, what's going to happen is light will actually slow down and it will bend closer to the normal. What do I mean by that? If let's say without any refraction, if let's say the light was supposed to go straight down like this, because the speed of light here slows down, what's going to happen? It will bend closer to the normal, and thus you'll have this thing here instead. Okay. But when the light enters from more dense into less dense this time, which in this case here is the glass into the air, because yet again the speed of light changes, right? In this case here, the speed of light is actually increasing. And because it is increasing, if let's say this was the normal trajectory that the light was supposed to go, what happens is it's going to bend away from the normal, and yet again it will bend like this here. Okay. Now, there are a few key things that you need to know in terms of this scenario here. Number one, obviously, is that if light enters from less dense to more dense, light is going to bend closer to the normal. If light enters from more dense to less dense, it is going to bend away from the normal. Okay. A few key points here is that number one, this is what we call the incident angle. Guys, if you recall what I mentioned last week, which only Suen here and the rest of the online guys here are here. Right? The angle, anytime you're measuring the angle, right, it is always with reference to the normal. Meaning to say, in your exam, right, they will sometimes give you this as your angle, this as your angle, or this as your angle, and they'll ask you to choose which one is the incident angle. Guys, this is like a sin to get this question wrong, guys. It's a sin. You need to know that all the angles are always with reference to the normal, guys. Meaning to say, guys, this is your incident angle, this is your normal, right? Your angle is always in between them, in between the incident ray and the normal. This is your incident angle. And where is your refracted angle? Your refracted angle, same concept as well, will be with reference to the normal and the refracted light ray here, right? And in other words, this is your refracted angle. And since most of you guys here learn mathematics, right? You know, in mathematics, the Z rule, you know, the Z rule here, if let's say these two lines are parallel to each other, right? Are you going to fall asleep soon? Okay, guys, if you know the mathematics rule here, right, if this is a zero and these two lines are parallel, this angle is going to be essentially the same as this angle, right? Everyone learns this in mathematics, right? This here is your normal and this here is your normal. If these two are your normal, it means to say they are both parallel, right? And if both of them are parallel, it means to say this angle is also your refracted angle as well. Okay, meaning to say if this is refracted, and this is incident, right? That means to say this will be your incident angle as well. Guys, pay very close attention. This is very important. It is asked in many of your exams. Oh shit. It is asked in many of your exams, guys. This angle and this angle is supposed to be the same thing. This angle and this angle is supposed to be the same thing as well. Okay, very, very important. You know, in exam, right, how would the question like to trick you guys? You know how would like to trick you guys? They like to give you something like this. Instead of giving you the full diagram like this here. My iPad lagging. My pen off. Battery. Oh my god, it's actually off. Okay, good. Forgot to charge it. Nice. But anyways, okay, let's change it back into. Yeah. Okay. Can you guys see my drawing online? You guys, can you all see this? Can you guys see this drawing already? Can you guys see the new scribble drawings? Hey guys online, can you see it? I'm pretty sure those are offline can see, right? Hello, everybody online. Can you see this? Can you see? Wait. Oh, yes. Thank you, Jaded, for the quick response. Everybody else, pay attention. In your exam, right, this is supposed to be the full structure of the diagram, right? This is supposed to be the full structure. But in your exam, you know what they like to do? They like to give you until here only, right? They like to make you see this only. And if, let's say, guys, you are given this only, right? what's going to happen is, right, they will trick you. Pay attention, you will be asked this question later on, guys. Everyone pay attention. They will trick you, right? They'll make you think that this is your incident angle and this is your refracted angle. Guys, I want you to all know that this is definitely not the case, because the full diagram looks like this. And because the full diagram looks like this, this is your incident angle, this is your incident angle, this is your refracted angle, this is your refracted angle. If I want to cut all the bullshit short, right, guys, basically, any angle that is inside the glass is always considered the refracted angle. Any angle that is in the air is always considered the incident angle, guys. Very, very, very important. You will be asked in this in your exam, and it's the most common way students lose marks because of this. It's been happening since the beginning of time already. Please, let's break the cycle, and this year you will all be different. Okay. So, having said that, close this. Okay, I need to share a different screen right now because I'm an idiot and didn't charge me. And anyways. Okay, guys. So if you look here, these are the first things you need to know, guys. Basically, look at this first example here. This is the one I talked about. If today the light rays enters directly perpendicular against the surface, no refraction occurs, right? So if you look at the statement here, light passing through a glass block at right angles to the surface will not be refracted, right? The rays will pass straight through, right? Logical, makes sense. When, however, the light travels from air, which is less dense, not less dense, guys, it's clearly a typing error here, right? It's a less dense to glass, which is more dense. Light is actually going to bend towards the normal, okay? It will bend closer towards the normal here, right? And finally, of course, when the light travels from more dense material to less dense material, in this case here, the more dense is obviously the glass, the less dense is obviously the air here, right? Light will bend away from the normal. It will bend away from the normal here. Okay, everyone? Anyone confused with whatever I've mentioned so far? Anyone don't know what I'm talking about? This is very important. It's like the basic understanding first, guys. This is just the basic understanding. Of course, it will not be so easy in your exam. It's just a basic understanding. Okay. So looking at these statements here, I think there's nothing to copy, right? 全部是给完你们了，是？
No.
Yeah, there's nothing to copy here. Okay, so from here, why does light bend away when passing through different mediums? This is simply because speed of light has changed. Guys, always remember the reason why refraction occurs is simply because there is a change in speed of the light. The angle at which light is being refracted can be calculated using the refractive index. We are going to learn how to calculate refractive index in the next page. Refractive index, by definition, is the speed of light in a vacuum divided by the speed of light in the medium. Don't worry about this statement. It's not important. It's just a statement. Later, we'll go for the real ones. And of course, the higher the refractive index of a material, the higher the bending of light. Now, this is a common example of different mediums. Now, guys, refractive index wise, right, the less dense it is, the less refractive index it will have. For example, vacuum, which is essentially empty space, right, will have a refractive index of 1. Air, which has some air molecules in it, will have a refractive index of 1.003. Water, which is more dense, will be higher. Glass higher, diamond is going to be higher as well. Now, the refractive index is basically an indication of how much the speed of light is going to bend. A very common use of this information here is an explanation of why Pasar Malam diamonds are so shit compared to the Pokong diamonds in real life, right? You know Pokong, right? Pokong, the jewelry shop in Malaysia. Okay, but anyways, for those who do not know, Pokong is a very famous jewelry shop in Malaysia that sells real diamonds, gold, and whatnot. Let's imagine, guys, today for a real life scenario, because right now we are equipped with the power of science, right? Today we look at a real diamond that is bought from Pokong versus a shit diamond that is bought from the Pasar Malam. Okay, this is a shit Pasar Malam diamond here. Okay, so you know, like in cartoons, you always see that when you open a diamond, it kind of like shines. It kind of shines out, right? You know that there's some science behind it, you know, because diamonds generally have a very high refractive index, right? What happens is, right, when light enters the diamond here, it will actually go through something called total internal reflection. And because it goes through total internal reflection, right, the light is able to cover more grounds inside the diamond, and thus it seems like the diamond is shining from within. Okay, it's not shining from within, it's just a better trap of light which causes it to bounce inside, which makes it more bright. This is due to the high refractive index. Compared to a pasar malam diamond, yeah, light will still enter the pasar malam diamond, right? But of course, it's made of glass, right? It's from pasar malam, right? Because the refractive index is so low here, as soon as the light enters the diamond, maybe it will bounce up, but it won't bounce much on. Maybe it will only bounce once. Can you see the amount of light that's in here versus the amount of light that's in here? That's why, right, they always say that real diamonds, especially the expensive ones, seems like they're shining from within. But you know for a fact that there's no light source from diamond. It just seems more bright because more light is trapped into the diamond itself. You guys get what I mean? And this is one of the applications of refractive index here. Okay. Yes. Okay. So, anyways. That's just the understanding of it. Right now, let's go into the important part, the calculation of refractive index here. Guys, in your exam, there's going to be 3 forms of formulas for the refractive index. The first formula is going to be sine I over sine R. The second formula is going to be C over V. And the final formula is going to be 1 over sine C. Okay, but let's go through it one by one first. Let's go through it one by one first. Okay. Don't copy first, everyone. Please pay attention. Okay, let's go for the simple formula first, right? The first formula that you're supposed to learn, let's use a different color. Okay, basically N is equals to sine I over sine R. Okay, now I want everyone here to know that this I is, yes, basically the incident angle, and this R is, yes, is basically the refracted angle. If today the exam is lenient, right? Let's say, for example, they give you one glass block here. They say that, okay, this is the light ray, then it enters the glass and the normal, and this is they give you this angle. Let's say this is like 40 degrees, and let's say this is 30 degrees here. Okay, with these 2 angles, you can straight away calculate the refractive index already. How do we calculate it? Yes, it's just simply substituting it in. It's N equals to sine 40 divided by sine 30. Press this into your calculator, and you'll get a very small number that is close to 1 mark. Okay, press this and tell me how much you get. Sine 40 divided by sine 30. Where's your calculator, Eugene? Bloody hell, you came to physics?
I know your answer is anything more than
Shut up. You 1.28. Okay. Oh, you bring a calculator. What the hell? You come to physics class without a calculator one? Does he know? Do you do that for the math class also?
yeah.
You're in a calculator, good, very good. Bring a calculator, are you then? You fool. Okay, so let's imagine now, right? The refractive index here, N is equals to 1.28, right? It means to say this thing here is 1.28. Guys, I have a few things that you must be very careful of when you're doing the refractive index. Well, number 1, this I will forever be the one in the air, and this R will forever be the one that is in the glass. Very, very important. Oh, is it 1.29? Hold on. Okay, hold on. Give me 1 minute. I have something. 1 minute, everyone. Wait. Okay, yeah, so anyways, it doesn't really matter 1.29 or 1.28. Anyways, whatever, right? This is not the important part. You know how the exams will ask you guys in your exam, right? Usually they won't give you such a nice number here. right? Or such a nice situation here, right? How they'll give you is they'll give you something like this. Let's imagine today I have a glass block here. Okay. Let's imagine I have a glass block here. Okay. In your exam, you know how they'll say they'll be very jingak on. They'll be like, okay, guys, this is your incident ray. They'll say, they'll even label that this is your incident ray. And then they'll say that this is somewhere down the line here is going to be your refracted ray, right? Then they tell you that the refractive index N is going to be equals to 1.5. If, let's say, guys, they give you an example here, let's say like this angle here, right? This angle here is 30 degrees, right? Then they ask you to calculate the refracted angle. How are we going to do this question here, guys? What do we do? First and foremost, is this 30 the incident angle? Is it? Is it going to be the incident angle? No, it is definitely not. Regardless of it, guys, regardless of whatever the question may state for you, when you're doing the calculation, I want you to know that the I will always be the one in the air, and the R in terms of calculation will always be the one in your class. Okay, so in this scenario here, if let's say I'm asked to find the refracted angle, right, which is not the refracted angle, it's the incident angle, I'm actually supposed to find the incident angle. So if I were to do the calculation, it will be like N is equal to sine I over sine R, right? Then in this case here, it will be like 1.5 is equals to sine what? 30 or I? Should I put 30 here? Should I put 30 here? No, it should be an I, and then it should be sine 30 here, guys. And from here, once I have the equation, it's just a matter of mathematics, right? It'll be like 1.5 times sine 30 is equals to sine I. Then after that, my I will be equals to basically shift sign, right? I think all of you guys have learned to press the shift sign button, right? Press shift sign, then you'll see this sine -1 symbol in your calculator, then you bracket everything. Press this in the calculator, and most likely you're going to get, if I'm not mistaken, 19. Oh shit, not 19, sorry. How much? Can you press this in your calculator and tell me? Shift sign bracket 1.5 times sine 30. How much would that be? Good, 48. Okay, let's say 48 lah. 48.6. 48.6 degrees. 48.6 degrees is going to be the correct answer. Why? Because I know that this is glass and this is air, right? From more dense to less dense is supposed to bend away from the normal, right? It's supposed to bend away from normal, meaning to say this angle here would have been 48.6. Guys, if let's say, guys, you are a fool, right? And you decide to put the 30 into here, what you're going to end up with, right? Your answer would be a wrong answer, which is like, I think it would be somewhere around 19.6 or something degrees. Guys, if let's say you ever do these kind of questions, I want you to think back about the fundamental understanding of how light ray works first. Light ray is supposed to bend away from the normal when it goes from glass to air, right? Away from the normal. If this is 19 degrees, wait, this is even closer to the normal than the original angle, right, guys? Which clearly doesn't make sense. Very important. Always don't just follow the mathematical formula and everything, right? Anyways, this is physics, right? You're not supposed to memorize it, you're supposed to understand what is going on, right? So this is how we use this formula here. And the second formula is very straightforward and easy, right? The second formula is basically N equals to C over, hey, don't copy first, listen first, right? C over V, basically, right? We're just doing some simple calculations only. In terms of N equals to C over V, this C is the same C as Einstein's famous equation. You know Einstein's famous equation, right? E equals to mc squared, right? E equals to mc squared, I'm sure. Have anyone of you guys heard it before? Good. Right. Have you ever seen this before? No. Okay. It's a generation gap kind of thing. But anyways, it's a super famous Einstein equation, E equals mc squared. This c is supposed to be the speed of light, which just now I've mentioned is going to be 3 times 10 to the power of 8 meters per second. Just a quick one on Einstein's equation here. He says that all energy form is basically just the mass multiplied by the speed of light squared, right? Obviously, if you have more mass, then you're going to have more energy, which makes a lot of sense, right? But it's not in your syllabus, so you don't have to care about this. You just need to know that C is a standard number. You need to know this number. It's like the same as your gravity number. It's 3 times 10 to the power of 8 meters per second. Okay? And this is the speed of light. Speed of light, SOL, right? And this V here, guys, this V here is basically the speed of light in a medium. In a medium, okay? The medium could be any medium. It could be glass, it could be water, it could be plastic, or whatever medium, but it cannot be air, because this is the speed of light in air already. This is everything else, the speed of light in every other medium, glass, plastic, water, rubber, blah, blah, blah. Anything that's semi-transparent that light can pass through, it will be in this equation here. Okay, everyone? Anyone online that's got a question or wants me to repeat anything I've mentioned so far, guys? Anyone confused with anything I have mentioned so far? If you have no questions, please copy everything down from here and attempt the 4 questions that is at the bottom. Một. 一個 class 上嚟，一跟住我用嘅 class。哦，所以我用呢個 class 你得。Okay, fine. But
you have to know where you got calculator for you. We don't know what the detail stuff to. 他学了差不多的。
轩轩好哎，他今天很早就到了。
对啊，我没有迟到。
Oh my god, what a compliment. I don't know. 有点难。他 year 7啊，他那么高了哈，我以为他。
对，他比我的高5块。
Oh my god， 我以为他是要 join 你这个 class， 然后跟我讲 year 7。
没有啊，他都很高。
是什么嘛？
他有1比7。
有个更高的。
很高呀 ！Oh my god. Okay, everyone, you're given 5 minutes to complete the exercise. We'll discuss the answers in exactly 5 minutes. 11. Oh God, Raj, there's something wrong with your book, is it? There's what? This page is not in? GG. So okay, let me send you the digital version of it first, then you refer to the digital page first. I didn't. Sorry, 讲多一次。Formula for the speed of light, n equals to c over v. You see if you received it, Raj. I think, yeah, check your WhatsApp. Ooh. Okay, yeah. God. Guess it was a printing error kind of situation. Okay, guys. It seems like some of you guys are not done yet. I'll give you guys an extra 3 minutes to attempt whatever questions is not done yet, guys. Then after that, we'll have to discuss the answers already. 3 more minutes, guys. Yeah. Eugene, which chapter are you in school right now? Do you know?
No more school.
What do you mean? Like, where did your school ended?
Ended yesterday.
Yeah, but where did physics ended in the syllabus? Do you know?
We were talking about gamma ray radiation.
Huh? Gamma ray radiation is almost the second last chapter in the syllabus already.
So yeah, next month.
Yeah. Yeah, but then you finish the syllabus like 6 or 7 months before your exam.
Not really. Finished the rest of the year. It's in some lot of chapter, but I learned it 2 weeks ago.
Oh, you learned this? Then electricity chapter you learned already, yeah?
Oh no, that's why there is a year that that's why we learned the chapter before our exam, but then it was like only halfway through the exam should be half. Like it learned somehow somehow with the COW.
What?
Yeah, and then we did experiments after the exam.
Yeah. Weird. Extremely weird.
Yeah.
It's okay. Don't worry, I'll cover the full syllabus with you guys anyway. Yeah, for sure. So this is the shit calculator. Oh, this is a financial calculator. It's not even a scientific calculator. Look. No wonder the color is so different. Oh well, a shit calculator. Okay, guys. Due to the time constraint, right? Let's go through the questions together real quick. Okay. I think this is in the notes, right? I don't know. Some of my students, they tell me that this is actually inclusive of the notes, but in my version here is missing the refractive index. Do you guys have a refractive index on the first question? Oh, yeah, weird. I don't know why for my version I left it out all the time. Anyways, here you're clearly supposed to use the n equals to sine I over sine R formula, right? Oh shit. Sine I over sine R formula, right? Which in this case here will be 1.33 is equals to sine incident angle over sine 30, right? Press that in your calculator and how much are you going to get? How much degrees are you going to get for this one? 2.66 肯定不对啊 2.6
Sorry.
How much? Okay, anyways, the working is supposed to be like this. 1.33 times sine 30 is equals to sine I, right? And sine shift sine -1 is 1.33 times sine 30, guys. You're supposed to press all this in the calculator. How much do you get? 40 what? 41.7, three significant figures, 41.7 degrees, guys. You're supposed to get this. And after that, find the refractive index from the glass, from the diagram. This is 40 and this is 25. Obviously, you're supposed to use the n equals to sine 40 divided by sine 25 here, right? Press that into your calculator and you'll get how much? 1.5. Exactly, 1.5. Nice. Okay, I don't know the calculation, but I know the working because I don't have the calculator. All of you guys go do it yourself. Shut up. Find the refractive index of the glass from the diagram. I had a lot of common problems with this question, guys. This is 30 degrees, by the way. It's not 50. Did you see it as 50? Yeah, which is definitely wrong. Refractive index is not supposed to be smaller than 1, guys. So from here, yet again, you're supposed to use sine 40 divided by sine 30. And if you press this into your calculator, you'll get 1.3 as your refractive index, guys. Always remember that your I must always be the one in the air and your R must always be the one in the glass block. Very, very important, right? Then after that, find the speed of light in the glass from question 3, given that the speed of light is this amount. Obviously, you're supposed to use the n equals to c over v formula. In this case here, it will be 1.3 is equals to 3 times 10 to the power of 8. And it will be here, which you're supposed to find, right? If you press that in your calculator, I think you will end up with v as 2.33. Is it 2.33 times 10 to the power of 8 meters per second? I don't know. I don't know the calculation. I don't know. But basically, it's supposed to be 3 times 10 to the power of 8 divided by 1.3 lah, right? And how much do you get? Say that again. 3 times 10 to the power of 8 divided by 1.3. Yeah, it's going to be a very good number. 轩轩，你有找到吗？这个？哦，你没有做到了啊，这一边。Eugene, how much do you get?
It's it's a 2.30769
拿，给我多。Yeah, divide by your refractive index. Yeah. How much? Okay. 2.31. Okay lah, 2.31 lah times 10 to the power of 8 meters per second for sure. Right. Do your own calculation. My working is correct, but my calculation might be a bit wrong because it's relying on someone else. Yeah, but anyways, this is how you're supposed to do it, right? Then finally, the last part here, this is a bit more on the realistic part in your IGCSE questions. Given that the speed of light in the vacuum is this amount, this is supposed to be a V. Find the incident angle when the refractive angle is this amount here, right? So first and foremost, you're given this information and you're asked to find the I and R. By right, if you're supposed to use I and R, if you're given I and R, you're supposed to use the sine I over sine R formula, right? But you do not have the refractive index. Instead, in order to find the refractive index, you need to use this information. You're supposed to use the n equals to c over v formula, which in this case here will be 3 times 10 to the power of 8 divided by 2 times 10 to the power of 8, right? This is your first step here. Then after that, you're going to get a refractive index that is clearly 1.5 because these two cut off, right? Then with this refractive index, you can find the incident angle using the n equals to sine I over sine R formula. In this case here, your I will be don't know, but your R will be 25. So it's going to be something like, isn't it speed like? Oh yeah, I think this is a, yeah, this should be in the medium, not vacuum. My bad. Thanks for the correction, Raj. That is very sharp of you. But anyways, from here, right, you're supposed to use the n equals to sine I over sine R, which in this case here will be 1.5 is equals to sine I over sine 25. Yet again, you press everything into the calculator, you should arrive at your I somewhere around 40 something, if I'm not mistaken. Press your calculator and tell me. 1.5 times sine 25, then shift sine the answer. How much would that be? Huh? 0.01. Definitely not. How much? 39. 39.3. Yeah, assuming the calculation is correct. Right. You're supposed to get 39.3. Very good. Okay, you're supposed to get 39.3, guys. Please, for those who did not do this last two questions, I highly recommend you doing it at home, trying it out, because you will be asked in your exam these kind of scenarios here. Okay, guys. The first one, 41.7 according to Eugene. Push all the responsibility. Yeah. Okay, guys. Yeah, but this is what you're supposed to know. Okay. Let me do one more quick concept for you guys. We'll revisit this next week, guys, but I want to leave you guys with some homework to do as well, guys. Everyone give me extra 10 minutes before I let you go today, guys. Okay, the final thing that you're going to learn about today is basically understanding how critical angle and total internal reflection work. Okay, so what is critical angle? What is total internal reflection? First and foremost, in order to understand those, let's understand how light waves behave again. Right, so let's imagine today, right, I have a glass block here. Okay, this is a very nicely shaped oval or half circle glass block. Okay, so when the light enters from one side to another, bear in mind that the reason it doesn't bend here is because it is going at 90 degrees, guys. It doesn't bend here, right? But obviously at this angle here, it is not 90 degrees, right? And because it's not 90 degrees, what's going to happen? Will the light bend closer or away from the normal? Anyone? Closer your head. It's supposed to bend away from the normal. Right. From glass into air, this is clearly glass, this is clearly air, right? So it will bend away from the normal. Okay. Anyways, it's supposed to bend away from the normal. What's going to happen is, if today I increase my angle of incidence, right? Let's say I increase my angle of incidence here, the light is obviously going to bend more or less away from the normal. It's more. It's going to bend more away from the normal. What do you mean? Okay, it's because I'm drawing with the mouse right? But yeah, right. So this angle, as I increase more of the incident angle, the ray is going to bend away from the normal even more. It will reach a point where it cannot bend anymore. This is what we call the critical angle. Why can it not bend anymore? Because at this critical angle here, this is the critical angle, guys. The refraction is at maximum already. It cannot refract anymore. This is what we call the critical angle. Critical angle, by definition, is the angle of maximum refraction, which in other words is 90 degrees, because you cannot refract any more than this already. So what happens If today I continue increasing the angle of incidence here, what's going to happen is this is essentially what we call total internal reflection. I'm pretty sure everyone here has experienced total internal reflection before. You probably did not notice it. But before I proceed on, anyone don't know how to swim here? Anyone? You don't know how to swim, seriously? Shut up, you idiot. Anyway, right. So let's imagine this is a swimming pool, right? If you ever dive deep down into the swimming pool before, you'll notice that sometimes when you look up into the surface, you'll see that there's a reflection of the tiles on the ground, right? Have you guys ever experienced this before? No? 下一次你就可以了。你下次你游泳，你 dive to the bottom of the sea of the water， 然后你看回上去，你看回上去那时候 there will be a certain angle 你会看到 the reflection of the tiles 的。Okay, why this is occurring? This is because it is called total internal reflection. Total internal reflection can only occur when the light is going from more dense, which in this case here is water, into less dense, which is in this case here air. I repeat, total internal refraction can only occur from more dense to less dense. Meaning to say, if, let's say, Eugene, today, if you were to stand outside of the swimming pool and you were to take a piss onto the ground and you were to see your own reflection in this piss here, this is not called total internal reflection. Shut up. This is called just normal reflection. Okay, why? Because it goes from less dense into more dense. This is reflection. Total internal reflection is always from more dense into less dense. Okay, very, very important. Everyone must know this. Okay, all right. So from back here, looking back into this, total internal reflection can only occur when the incident angle here exceeds the critical angle, meaning to say, if, let's say, for example, I say that the critical angle is 40 degrees, right? Anything more than 40 degrees is going to go through total internal reflection. Even if it is 41 degrees, it is going to go through total internal reflection, which is represented by this light green light here. Okay, everyone, just need 5 more minutes and I'm done already. Give me just 5 more minutes and I'm done. Okay, so yeah, I think we'll continue this next week because the students want to have the class really. But guys, if you look at the statements here, I think you can go have, hey, can everyone please copy down this formula first from the next page? Because I expect you guys to do some exercises. Guys, your homework for today is basically going to be these 4 questions at the bottom here. This N is yet again your refractive index. This C is your critical angle, guys, is your critical angle here. Copy this down first. We'll continue this next week, guys. I'll repeat a little bit more on this chapter next week as well, guys. Yeah, just 4 questions. Just attempt it. A little bit pathetic for sure, but it is what it is. All right. Okay. Please do attempt. This guy does his homework. Very good. You better do the homework. I tell you, next year if you never do, I'm gonna come physically abuse you. Huh? No, not for fun. For real. Physically. Okay. 这个就是 critical angle. 这个就是 critical angle because 这里是90度了嘛 ,90 degrees 了 anything more than the critical angle 就是 total internal reflection 了。你看到吗 Yeah, refer to your notes. Everything is quite standard at this point. But guys, I'm so sorry. I have to give up the class already right now. Everyone, we'll continue this next week, guys. I'll see you all next week. Oh, for those who have any questions, you're more than welcome to stay, by the way, to clarify anything. But for those who have no questions, that will be it for today. I'll see you all next week. Good.